First question of the day. We asked you guys a lot of questions today. First one. What causes the ultimate dispersion of heat away from the equator? How do we get heat away from the equator? No. What about the ocean? Because you see the diagram? What's going on up there?
Moving the heat.
Okay.
It's because of the shift.
Moving the ship.
Or like the pole.
What about the pole?
The rotation of the Earth's axis
Yeah.
goes around every year, so it's split like straight.
No.
Well, I thought it was the way that the Earth is facing.
Oh, absolutely. But it doesn't bend in place.
I'm not trying, like I said, to bend the twist. It's just like,
Well, if I have an angled stick like this, and here's my sun. Right here's the north pole, south pole down here, right? So here's my sun. So right now, what season are we in? Try again. Look at the orientation of my planet.
which side of the
North pole. So we're in winter, we're facing away, right? Now it doesn't like rotate like this, and then here we go again. It stays on that angle. It simply goes around the sun. When I'm here, notice that both the south and north get an equal amount of heat. That's our equinox. Okay, we have our autumnal and our vernal equinox. Autumnal meaning fall equinox, vernal meaning spring equinox. So we have those two equinoxes, and that basically means we have an equal amount of daytime and an equal amount of nighttime. Okay, that's March 21st and 2nd, and then August 25th, right? So we got to know that. Okay, now same orientation. Now this time, I come around here. Now what's happening with my North Pole? It's facing in toward the sun, so it's getting more direct heat from the sun. And therefore, what season? Summer. And I'm back around here. I'm now in the fall. So guys, when we talk about this, it's not that the tilt goes back and forth, it's the football. I don't know. I just want to make sure we make that clear. It stays on the same slant. It's just that slant moves around the sun, revolves around the sun, and that's how we get our different seasons. It is from the tilt of Earth's axis, but it doesn't simply wobble back and forth. Right? So when we talk about this, we understand that right now, if you look at this right now, we're switching back and forth between the seasons. So during the summer, we see more heat at the top, and then it moves back down south. We get our winter. But how does that heat get redistributed away from the equator? What about the ocean? How? It does carry the heat. How? What do you mean the flow? What do we call those flows? Starts with C. Currents. Oh, ocean currents. If it wasn't for the ocean currents redistributing the heat away from the equator, we would have no weather. It would be constant. It is this continual dispersion of heat. Since we do have unequal heating of the Earth, it is this continual dispersion of heat away from the equator and toward the poles that ultimately give us our climates. And the climates, therefore, give us our weather. And climate, again, is long-term. And tomorrow we'll be looking more at what these different types of climates are. But climate is long-term. Weather is your day-to-day material. It's what's happening every single day. So we look at the ocean currents. The key thing I want you guys to remember about things in nature, everything in nature moves from highs to lows. We talked about that before. Okay, it's almost common themes in this class. Everything in nature moves from highs to lows. So when the equator gets really hot, it's taking that heat and moving it to where? So that's why equator is really hot. Where is it moving the heat? Toward what? Toward the pole. So I'm moving out to where my poles.
only that heat though, where it's the hot spot, the red spot.
Yeah.
Only staying between the Tropic of Cancer and Capricorn, right?
Actually, we do get a little bit of red that comes up beyond that. But yes, if you look right here, those are your what we call the tropics. You have your Tropic of Cancer and your Tropic of Capricorn. Now, I understand what you're thinking, that the red would have to stay in those lines. It's not necessarily that. The 22.5 degrees, no, 23.5, sorry. Those are basically the borderline as to how far the sun would go in terms of its maximum potency. Okay. So that's kind of the range. It'll basically maximize itself to 23.5 degrees north and 23.5 degrees south.
Go back with this computer.
Welcome. So in this diagram, we can actually see all the ocean currents that we have in the world. And notice we have two types of ocean currents. We have blues and we have reds. What's the difference?
Red's warm, blue's cool.
Say again?
Red's warm, blue's cool.
Okay, so red is warm, blue is cool. Alright, now that's kind of important.
Doesn't that have to do with the way that the sun, the oceans are always trying to
There we go, good job. Okay, the oceans are trying to reach equilibrium, trying to get to a stable temperature. That's another one of those major things that we know for this unit, is that everything is trying to reach equilibrium. So while the equator portion of the ocean is really warm, it's trying to balance that out and get the heat away and balance it out with the really cold temperatures of the poles. So when we look at this, that's the whole point of the currents. They take that heat and they redistribute it. If you look up here, and we look at the one that we are probably the most familiar with, the Gulf Stream. Now, I know we've talked about this many, many times before. Why does Northern Europe have a very similar climate to what we have here in Indiana, despite being level with northern parts of Quebec and Ontario? And it's all because of the Gulf Stream. The Gulf Stream takes that heat, comes up, it hits the east coast of the United States, and bounces back across the Atlantic, and brings with it all that warm, moist air. Okay, why is it moist? Where's all that moisture coming from? It's over an ocean, isn't it? A lot of water in the ocean, right? Okay, so we see a warm, moist air. A lot of that moisture's got to come from somewhere. So it's coming off from the ocean. That's where most of our moist comes from. And so it comes up and it brings all that moist air with it and actually kind of warms the entire continent of Europe and gives it a nice, livable environment. If the Gulf Stream were to ever get shut off, this is what they talk about global warming and why it's such a big deal, is with the ice caps here in the Arctic that melt, it brings in fresh water, which eventually could shut down the Gulf Stream, or in a worst case scenario, not just shut it down, but actually prevent it from reaching into Northern Europe. The entire breadbasket, what's a breadbasket?
Like,
You guys never heard that phrase before?
Isn't Indiana breadbasket or like?
We're part of the United States breadbasket. What is it?
Corn.
Corn,
Brown.
grains, all right? So any of your grains that are grown, the majority of those things that are grown are actually within this region of France and Germany. So this is the breadbasket of Europe. If that ever gets shut down, you're going to lose that climate that comes with the Gulf Stream. This will easily shift down south. And so all of a sudden this will become like trying to grow those kind of crops in northern Canada. How well is that going to work out? Not well at all. And so that's one of the concerns that we have with global warming is that yes, this will happen. My theory is it will happen. There you go.
What?
It's not going to matter. You can try and prevent all the pollution you want. It's going to happen. It has happened. It will happen. It will happen again. It'll get better. It'll happen again.
You said it's
It's natural process.
Don't we
Cycle.
also have mountains taking carbon dioxide out of the air at all times?
We'll still have volcanoes that are releasing carbon dioxide.
Didn't we talk about the global warming and said how it's such that low percent?
Yeah.
Why is it that big of a deal? It's just that little bit.
But it's heavier, so it's down more
You're,
in the
you're still,
ozone.
you're still a small portion of the water, right?
Remember, all that carbon dioxide is actually sitting toward the surface of the Earth. The carbon dioxide prevents long-wave radiation from leaving Earth's surface. And therefore, what it does is it not only is Earth now being heated by the sun, but it's almost being reheated by itself. Okay? It's like the difference between sleeping outside in a sleeping bag and sleeping outside with no blankets.
All the
Okay, so if you're in a sleeping bag, all that heat stays within you and gets re-radiated back inside. Not too bad. You go sleeping without the blankets, and all that heat is simply released.
Mr. Thompson.
Hello?
Quentin, fine.
He's right over here. Hey, Quentin, you here? Yeah. All right. So here's some. Remember we talked about different climates. All the different climates that we have. This is actually a really good slide to kind of talk about that. And we have a lot. I want you guys to kind of write these down, have an idea of what they look like and the type of climate that's associated with them. Okay. So one of the first ones I want to talk about are maritime polar. Maritime is a key word that means what? Don't we have any maritimers in here? Anybody ever heard of maritime law?
I've heard of it, but I don't remember what it is.
As soon as you say it.
Okay, well, let me point out something for you here. Maritime. Maritime, maritime, maritime. Figure hand. Not maritime. Not maritime. Not maritime.
Water, like,
Holy, it has everything to do with water. Maritime means open water. So oceans, seas, bays, that's all maritime. So we're talking about maritime polar. Where's that at? It's in the poles, but it's over water. Okay, so you're talking about your polar oceans. And typically with maritime polar, cold and moist. Cold because where is it at? It's up in the poles, cold there. It's moist because it's over
Water.
water. Which is why, look at where this air mass sitting right over here. Okay, Oregon and Washington. Again, for those of you guys who are my big Twilight fans, right? Watching the movies, you should look at a lot of the scenes that are shot in Washington, even during the summer. It's cloudy and disgusting, and it's not warm. And despite being basically almost the same latitude as us, they're really not much farther north than we are. They basically have much colder summers and a lot more wet summers, and that's because of the moisture coming off the ocean and the air mass bringing with it cold air from the poles.
And
What that would be.
So,
maritime
cool and moist. Yes.
So the maritime tropic is far.
Yeah, we're still moist because it's over the water, it's over maritime,
More.
but it's very warm. And so that's going to be your maritime tropical, brings warm, moist air. Think about, again, look at this air mass sitting over the Caribbean. Alright, so think about Florida, Louisiana, parts of southern Mississippi, and Alabama. Those are all examples of warm, moist air being brought in. So those are your maritimes. We also have 3 continental air masses. We have continental Arctic. Again, continents don't really have a lot of water over them, so we consider them to be somewhat dry.
It's near the Arctic.
Okay. So all 3 of your continents are going to be dry. But the Arctic is very, very cold. That's going to be very cold, very dry. In fact, a lot of our polar regions are considered deserts.